All right, if I want to change this into degrees, what you have to realize is, isn't pi equal to 180? So if I say 4 pi over 3, aren't you going to change pi to 180? But I'm going to do a little bit different. I want you to realize 4 pi over 3, if I times that times 1, could I times it by 1 but do it as 1 as a pi and a 180? Okay, think about this for a second. If I multiply this times pi over 180, isn't that multiplying by 1? Isn't that equivalent? Just different units. Could I cancel the pi's now? Once I cancel the pi's, you now have 4 times 180 over 3. Can you reduce that? Yeah. That should leave you with 60. And 4 times 60 is 240 degrees. So if I want to make this into degrees, if I want to take this and make it into degrees, I'm going to take negative 7 pi over 6. I'm going to multiply it by 1. But a 1 such that pi disappears. So I want pi on the bottom, so the pi's disappear, and put 180 on top. So 180 degrees over pi. Won't the pi's now disappear? Because pi over 180 is 1, with just different units. So this would be negative 7 times 180 over 6. And can't this reduce to 30? And negative 7 times 30 is negative 210 degrees. So I want to change 225 degrees to radians in terms of pi. So 225 degree radians, so into radians, so 225 degrees, I want to turn that into radians. So I'll put that over 1, and I want to multiply that times 1. Now, here's the thing. For radians, don't you want pi on top? And so could I put 180 on the bottom? Again, if you want to change this to a radian, don't radians have pi up here? So don't I want to put pi on top this time and 180 on the bottom? Do you see over here I put 180 on top and pi on the bottom? Because here, didn't I want the pi's to cancel? For this one, don't I want to bring a pi on? So I put the pi on top and 180 on the bottom. It's kind of the same idea, just a flip-flop. Here's where it gets a little ugly, though. You now have to break this down, okay, so you can simplify this fraction. And for some people, simplifying this fraction is a little hard. So you have to find numbers that go into both. And what you hopefully notice here is it's 45. The bottom is 45 times 4. And the top is 45 times 5. Don't the 45s cancel? Which becomes 5 pi over 4. It might be hard to learn how to simplify these, but over time, you'll get used to it because you always are pulling out either 30s, 60s, or 45s because that's the measurements of degrees that are on the unit circle. For this last problem, I want to convert this to radians. So I have negative 450 degrees, put it over 1, times, if I want pi on top to become a radian, I put pi there, but I put 180 degrees on the bottom. And now I have to reduce. So I have negative 450 pi over 180, and I have to reduce that. So what would that reduce to? Well, hopefully you can see, possibly a little bit harder. It just depends on how you see it. But 450 and 180, do they have 60 in common or 30 in common? That's a little bit harder to see here. What do you think? Oh, wait, did I miss that? Isn't 90 going to both these? It's not 30 or 60. It's actually 90. 90 goes into both those. I didn't notice that. Because what you got here is negative what times 90, and what times 90 is the bottom? Well, the bottom's 2 times 90. What times 90 is 450? Isn't that 5 times 90? So can I cross that out, leaving me negative 5 pi over 2? Oh, that one's a little bit trickier. We forgot about 90. We could usually use 90s. I thought it was going to be a 30 or 60.
This makes sense now.
You're trying to get something to cancel out. You get a nice simplified radian right there.